All right, we are live and welcome everybody to our first stream of 2021. Uh, actually, I can't believe we've not done a stream for a while now, actually, right? Have we? How many
Surprising,
streams?
really.
Yeah, we've not done any streams
Zero.
for a while now.
Zero so
Yeah, we've
far.
done a
Yeah.
lot of videos, but not too many streams. So, welcome to our first stream of 2021. As always, my name is Abhay. I had a company called V45. We recently launched an awesome training product called AppSec Engineer. So, go check it out. With me is Nithin. I'll let him introduce himself.
Hey, folks. So I'm a security researcher and a solutions engineer at V45, and I also work at appsecengineer.com. So we've been working on a lot of trainings lately, and there's been a ton of research that's going along. And today we're just going to be speaking about that.
Yep. So yeah, today is gonna be kind of like a casual thing that we're gonna do. Basically, the one of the biggest questions that came about in December 2020 was, "Hey, Docker is being deprecated, or Kubernetes is not going to leverage Docker as a container runtime technology anymore," and that suddenly caused the entire Docker's, Kubernetes, pretty much all communities related to containers to just go up in arms. And of course, Kubernetes had to release a bunch of they had to release an article that said, "Hey, you know what, nothing is it's not as bad as you think," and all that stuff. I'll share that article a little bit later. It's not as bad as you think. It's pretty much the same thing. And it's but this at the same time, we believe that containerd is the best way to go, and that's why we're doing what we're doing. So today's stream is essentially us going to be we're going to be focusing on, and it's going to have a lot of live code demos and things like that. So we're going to be focusing on some of these things. We're going to look at, first of all, life beyond Docker. Now, the Docker is not going to be part, in the sense it's not going to be running as the main container runtime technology in Kubernetes. What is the alternative? First of all, is it a big deal, right? Is it a big deal even? Is it something that is earth shattering? Is it earth shattering? If it's not earth shattering, why is it not earth shattering? And if it's not earth shattering, what is the alternative? How does it work, etc., etc.? We're going to look at that. We're going to have a quick sneak peek into containerd, which is what Kubernetes and all the cool kids have decided to use. After that, we're going to kind of segue into a slightly different area, right? So we're going to talk about slightly more isolated container technologies and unikernels, right? So Nithin did an awesome article on unikernels. Nithin, you probably want to share the links with me later, or you can put it in the description.
We
He
can
wrote a
probably
very
put in the
nice.
description later.
Yeah, probably put it in the show notes later. Yeah, so Nithin wrote a very nice article on unikernels, and I thought, hey, why not combine both these things, because they're kind of coming at the same time. Rise of unikernels, fall of Docker. Not necessarily fall of Docker, but still rise of unikernels nevertheless. So basically, that's what we're going to be doing. We're going to be talking a little bit about the slightly more isolated, cool container slash unikernel technologies that we have seen. Yes, remember, these are still kind of POC for us, right? We have not deployed production workloads on this, except Lambda, of course, which we don't orchestrate. We don't really care about orchestrating Lambda. Amazon does that for us. But in this case, we want to look at some of these things that we think will make a pretty big difference in days to come. So with that, shall we get started? Nithin, shall we get started?
Absolutely. Yes. Let's go.
Awesome. Let's get started. So, first of all, let's talk about the whole Docker support being dropped on Kubernetes, right? I'm going to share that, that note. By the way, I'm going to share that link for that article. It's more a technical article which they've talked about why you should not be so worried about it. So this is the article which is on the Kubernetes IO main site, and as you can see, this announcement was made about a couple of months ago. And obviously, the community was like, "Oh my God, what's happening? Is this real? Tell me it's not true," kind of thing. But really, if you look at it, if you actually break things down into its core, you will see that it's not as big a deal as it is. Docker still remains the packaging technology. So let's talk a little bit about this. Let's talk about a few thoughts. Nithin, I think, has a containerd demo as well for us, which is going to be like basic containerd. Of course, you can do a lot more with it and orchestrate it and so on. So let's talk a little bit about what Docker is and what Docker isn't in the first place, right? So I'm going to share my screen, and I'm going to start quickly getting into that. So if you see here, this is basically, let me actually share the right screen. Hold on, this is kind of getting messy. Let me share the other screen, which actually has this, not the stream on it. So that's basically what I'm going to do because, yeah, so this, I'm going to share the screen and I'm guessing everybody can see my screen. Now, basically, this is what Docker. So Docker is not really a container runtime technology in itself, right? So Stuart says, hello, everybody. Hi, Stuart. How are you doing? So Docker is not really a container runtime technology, right? Docker is really more an orchestration system in itself. We've gotten so used to working with Docker that we think of it as, hey, this is this nice, cute little tool that sits on our desktop that we can run a bunch of containers on. At least that's one of the genius of of the Docker group that's made it so simple, right? So easy to use. It's so simple. Everybody, you can install it anywhere, you can run it anywhere. It works across. It works on Windows. It's so easy. They really democratized containers in a big way, right? And one of the things when we started, in fact, we do a lot of Docker training, Kubernetes security training, Docker security training. So when we started off the training, I think Docker was a monolithic application. Am I right, Nithin? It was Docker monolithic at the time.
It was, yeah. Back then, yes.
Yeah, so I think this was about 2015, 2016. When we started off the training, that time Docker was definitely, I think, monolithic. Over time, Docker actually started to break things down into its components, right? Into its bare components. And that's where it really became, it was clear that Docker was not this, hey, this was not this cute runtime technology. Docker is actually handling a lot of things. Docker is pretty much the Kubernetes on your desktop, right? In fact, especially with Compose, it's like a small Kubernetes on your desktop. Of course, it's a very, very naive analogy, a metaphor that I've used, but it's think of it like an orchestrator. When I think Docker, you don't think orchestrator. You think of this cute little binary that's sitting there and just helping you run containers. But that's a lot more than that. Docker handles networking. Docker handles volume mounts. Docker handles storage. It handles a lot of stuff. It kind of lifts a lot of the load. So when you're running Docker, what really happens is you're essentially talking to the Docker daemon, right? Which is a high-level daemon of sorts, a high-level process that manages all of these things, that gets things together. Think of it like the Kubernetes API manager of sorts, right? So the Docker daemon essentially handles all of these things, whether creating a network, creating storage, mounting volumes, environment variables, all that stuff, right? It orchestrates the process of running containers on your system, whichever system that is. Now, as Docker became non-monolithic, it actually broke it down into the third-party. It broke it down into smaller components. We saw that it had created a low-level or a lower-level container runtime called container D. It was definitely lower level than Docker because the idea, what happened was that Docker had to move towards a specification called OCI, or the Open Container Initiative. Was it the Open Container Initiative? Or
it was, yeah.
Open Container
I think
Initiative.
It was the initiative.
Yeah. So OCI is the standard. It's like the specification for containers, right? So you can actually check this out. There is an OCI. Let me pull up an OCI link a little bit later. But you can actually go on GitHub and read the specification. It gives you the Golang, the APIs. It gives you a JSON schema specification. It gives you all of that stuff. So the OCI is essentially, the world realized that, hey, Docker can't be the only game in town. We have to have container technology is too powerful. We can't obviously have just Docker doing it. So they created this Open Container Initiative where anybody could create a standard container imaging system, imaging scenario, and it also standard runtime practices and so on. Not yet RIP Docker. Santosh says RIP Docker, but not really yet. Santosh, Docker still. I still like using Docker to package my stuff, but we're going to be running it probably a little differently. Anyway, so Docker essentially, the container D was essentially a runtime or a lower level runtime than Docker. It was a daemon that allowed you to run OCI compliant images. So what used to be Docker images are essentially OCI compliant images. Now these OCI compliant images can run under any container runtime interface or any container runtime binary or any container runtime program, right? So it can run with Rocket. Rocket can use OCI compliant images. Docker can use OCI compliant images. Obviously, container D can run OCI compliant images. Now, since Kubernetes was already an orchestrator, the way they didn't need to use Docker in itself, right? So they decided that, hey, we don't need Docker, we need container D, because that's the one that's actually handling the creating of containers. And in fact, container D is not the only thing. Under container D, there is another binary called run C, which actually does the creating of containers and launching of containers and things like that, right? So if you look at it, container D is the daemon, a lower level daemon. Docker is the higher level daemon. And then below that, there is another process called run C that actually runs and that launches the container on whatever machine you're on. So if you look at Kubernetes in itself, right? So Kubernetes essentially uses all of these things to make that happen. So if you look at Kubernetes, you will see that Kubernetes pretty much does it like this, right? So you have the kubelet, which is the component that's running on the on your nodes or your worker nodes in Kubernetes, that has something called a container runtime interface, which is an API that talks to container D, which talks to run C, which runs your container, right? So essentially, that's how Kubernetes is doing it. So there is no real need for Docker. So even though you are using Docker on your desktop or Docker wherever, you're essentially creating an OCI compliant image or using an OCI compliant image, and that image is actually being run by container D and run C, right? So that's the big thing. So even though you don't necessarily, while Kubernetes is not necessarily going to support Docker or going to run Docker, it's not going to run Docker as a runtime because Kubernetes doesn't need to do that. It already has this OCI ecosystem, and it's going to run this OCI ecosystem with container D and run C, right? So that's basically what is happening. Nithin, you have anything to add to that?
Oh, not really. So all the panic that happened when people were saying no to Docker, right? So does that essentially mean that people will have to move out of Docker to Kubernetes, or can they still continue to stay on Docker, especially with EKS and AKS, all of them upgrading pretty often?
Yeah, actually, that's a good question. So all the cloud providers have already upgraded, right? When I say upgraded, they've already moved to container D. So they're not running Docker anymore on the worker nodes, right? Cloud providers have already moved to container D. That's it. So there's no Docker already on the cloud providers. But Docker is still going to be relevant to us, right? When you are creating images. So let's say I am writing some Node.js code or some Python code. I'm not going to be using container D to package my image. I can, but let's say I'm on a Mac and I need to write, I need to package it into an image and push it into, into a container registry and things like that. I'll still be using Docker to run all that. I'll still be using Docker Compose to orchestrate locally. I'll still be using all of those things. Of course, I could use Kubernetes for that as well. I could use Kind. I could use K3s. I could use all of those things. That is fine too. I could use, a hosted service like Octet or something. But the point is that I will still be using Docker to package my images. So it's just easier for me to do that. So think of it, I think of it, I don't know how others are going to do it. I'm not sure whether this is going to be the generally accepted opinion. But my take on this is that for me, Docker is going to be a packaging layer or a packaging technology, and container D, which is, again, I don't really care about when I'm running on Kubernetes, because Kubernetes is going to handle the heavy lifting, unless I'm on bare metal. And if I'm on bare metal, I need to have a container D, a binary installed, and all that stuff done. But in most cases, I'm not, right? And with, the Kubernetes packaging tools the way they are, it's much easier for, me to just run with the flow. And they're anyway going to pull down a container image from whichever registry and get the job done. Right? So that's basically what it is. Yeah.
Yeah. So the features when it comes to container D and Docker, it's going to be slightly different, right? So Docker, when you look at the features and functionality, it's going to be a lot more complex, and you can do a lot more things with Docker. But a simple command like building your images, right? So you cannot do that with container D. You'll still have to rely on something like Docker to build your images. And even if you want to expose or mount your ports to access, for example, a web application running inside a container, that's going to be fairly hard to do with container D, to be honest, right? So with Docker, you just use the -p command and you're off to the races. With container D, it's pretty hacky, right? So if you do the net equal to host and, mount all the ports there and what. So it can be pretty painful in container D.
The way I see it is that containerd is not meant to do that. It's just meant to run containers, right? The networking and all of that stuff is separate. So if you look at
Yeah.
Kubernetes, everything is separate, right? The network layer, the network plugin is separate. Your storage plugins are separate. Your runtime interface is separate. Your CRDs are separate. Everything is separate. So I think that's the view of the world that most of us are going to embrace, right? Where
Yeah.
we are doing these things separately and we have separate components to do these things, and that is good because the single point of failure model is also avoided, and then this overt emphasis on this one big thing or this one big product or one big service is also going to definitely reduce. So yeah, so that's basically that's basically about containerd. That's basically about how Docker is essentially going to, well, I say Kubernetes is not going to be using Docker for running containers. Let me put it that way. It's going to
Yeah.
directly be using containerd and runc,
Okay.
and it's going to do its job. So, Nithin, if you just want to do a quick demo of the containerd thing and just walk us through what you have there.
Sure thing.
Uh,
Absolutely.
any questions for folks on the stream? Let us know. We've gotten some comments. RIP Docker, like I said, not yet though. But yeah, we're still.
All
I think
right.
we're still likely to see it. You want to share your screen?
Assuming my, oh, it is shared, isn't it?
Oh, it is. Okay, I need to add that to
It
the
is,
screen.
yes. Okay.
Yeah.
All right.
There we
So one of the first things I'm going to do, like we just discussed, right? You cannot build images directly from containerd. So you will have to pull it from a registry. So what I'm going to do right now is I'm just going to pull a simple Redis Docker image from the Docker Hub registry, but using containerd. So I'm just going to say
Nithin, do you
containerd
want to
image
increase the
pull.
size of your or resolution of your screen because it's kind of
Is that
smallish?
better?
Yeah, much better.
That's
Thank you.
slightly better.
Appreciate
Okay,
that.
perfect. All right. So
I think we have a couple of questions on the stream, Nithin, before we continue, just so that we can
sure
wrap
thing.
up the
Let's go through
questions.
them. Yep.
Yeah. So, what's the difference between Docker and containerd, and how a user can take a decision to use what? So, most of the time, Docker, and like I said, Docker is more orchestration. Containerd is the runtime daemon that's actually running the container. It's just responsible for running the container, and making sure that the container is pushed over to that shim and runc. I think that's the big difference. How does the user take a decision? Really, it's not, especially if you're using Kubernetes, that decision is not up to you anymore, right? Kubernetes actively said 1.2, they're going to show a deprecation message. 1.22 end of 2021, they're not going to just allow Docker. So if you're on bare metal, this affects you more if you're on bare metal, right? That's the thing. If you're on bare metal, that's the problem. So if you're on Kubernetes, it just won't work. It just won't work with Docker from 1.22, which is the end of what they've planned is the end of 2021, right? So yeah, sorry, Nithin, please continue.
I think we have one more question from Santosh.
Oh
If you want
yes.
to go
Oh
ahead and
sorry.
answer.
I look like I've. Can we run Docker and Kubernetes without any runtime overlapping? Right now, yes, but I think from 2021 end when Kubernetes become 1.22, I don't think it's possible. I don't think so. I'm not sure. Although on the node, I think you can run, but Kubernetes will not use that as the runtime, runtime interface or the runtime that it's going to use. Yeah. So
Awesome.
thanks for that, guys. Yeah. Sorry. Go ahead.
So I'm going to get back to this, right? So
Yeah.
then I've essentially pulled a Docker image or a container image from a registry, right? So you will have typically Docker by default defaults to Docker Hub, but that is not going to be the case with containerd, right? So you have to specify the registry where you're going to be pulling your image from. So I just pulled a simple Redis image. Any image on Docker Hub, you should be able to pull fairly easily. And if you want to list out the images, previously it's Docker images, right? So, but in this one, it's going to be containerd or CTR images ls. And it's going to tell me that, hey, you know what, you have the Redis image on your machine right now. So
Just
we
basically,
have,
Nithin, just to clarify, CTR or this is equivalent to the Docker CLI, right? It's just a CLI.
this is the CLI. This is the CLI
Okay.
for containerd essentially.
Okay, cool.
Yeah. So let's assume I want to create a container now, right? So I have an image which I want to go ahead and run and create a container. So what I'm going to do right now is I'm going to run the same CTR command, and I'm going to say container create, and I want to run the Redis image, right? So in Docker, previously when you run an image, and if that image does not exist on your machine, by default, Docker is obviously going to go ahead and pull it. That is not going to happen with container data. So you have to ensure that it is available on your machine, that the image is available on your machine before you go ahead and start running containers from it, right? So that is something that you need to know. And if I want to list out all the containers that are running, I can do that as well. So I can see that, hey, you know what, my Redis container is currently running. And if I want more information about the container, right? So about this particular Redis container, I can fetch all of the information as well. I'm just going to clear the screen and fetch the info. And as you can see, right, so you have quite a bit of info right here. And if you keep scrolling up, you can look at the destination, the mounts that have taken place, the rootfs, and all of the capabilities, right? So one thing that you can do is Containerd does support seccomp, right? So if you want to drop some of the capabilities or drop some of the syscalls, you can continue to do that in Containerd as well. So you can look at all of the permitted ones as well. I think something happened to the
Yeah, a
screen.
lot of cool ones, that a lot of fun ones that are permitted, Nitin.
Yeah.
As a security professional, you need to be better than that. I call
I'm
you
just
out.
using the default commands. And finally, if I want to go ahead and look inside a container or something similar to the exec to gain access to that particular runtime, I can simply go ahead and start a task. Right, so I can start a task and it's going to tell me, hey, you know what, my Redis is currently up and running. It is ready to start accepting connections and it's running on port 6379. But remember, this port is not exposed to your particular server or to your local network anymore, right? So that is not something Containerd is designed to do. It can, but it is not designed to do that.
So yeah, that makes sense because Kubernetes, in any case, it's going to be using its CNI and the plugin to actually give it the network, give it an IP address, the pod. So essentially, the pod handles the whole IP addressing, the network aspect of it, putting
Yeah.
it on the
So
bridge.
the way it
Things like
works in Kubernetes,
that.
right? So you create a service object. And the
Yeah.
service object is going to take care of all the communication with the pod that's going to be running your container. So on Kubernetes, it should be perfectly fine.
Yeah, no, I'm talking about the lower level, right? So in Kubernetes itself, so if you look at how the network itself, so you're essentially having this CNI container
Mhm.
network interface. You have the APIs, and that essentially talks to the network
Yeah,
plugin. And then you have obviously on the node you have the pod. The pod essentially has its own IP
pod IP.
address, and
Yeah.
you can use kube proxy and things like that. So I think networking in terms of Kubernetes is kind of dealt with, right? So that's basically yeah. But that's interesting. That so one of the things I came across was that Containerd, of course, since it is essentially a Go binary, you can use Go. It has Go binding, so you can actually use
Yeah.
Go to create your own CLI of Containerd. I think we have that article in there somewhere. Container. Let me try and find it. Containerd. Golang. Yeah, so I think you can actually create like a small sort of your own. I saw an example with that. Yeah, so you can actually use that. In fact, Alex Ellis's blog has one run containers without Docker article, which is very interesting because Alex Ellis is pretty knowledgeable about this stuff, so he really knows his stuff. And you can also use his OpenFaaS library. I'm just going to put that in the this one here. You can see that it's going to show up. This is so yeah, he's using a different way of running containers without Docker, but in this case, you can use Containerd and you can use its Go bindings to actually do that. So the next, so basically that's what it is, right? So Docker, while it's getting deprecated per se, the deprecation really goes is not going to affect you so much unless you're so much on bare metal. And most of us, most of the people that we know are not on bare metal. Although there are some companies that are still extensively going with bare metal on Kubernetes, which they are extremely brave people. I have to say. Just Kubernetes. I don't want to. I can't imagine managing a production grade Kubernetes cluster on bare metal. Props to those who can. I certainly can't. I don't think Nithin, are you brave enough to run it on bare metal?
Just maybe depends on what workloads I'm running on it.
No, I'm talking about something like a like a proper microservices
Yeah,
enterprise level
that's not
microservices.
recommended at all. Probably not. Yeah. That's not
Yeah, but there
recommended.
are people who do that. That's the weird part. Anyway, I mean, more power to them. But yeah, those people have to probably think about the whole Docker migration thing. That will, I'm sure, be non-trivial, because which means going into the nodes, replacing it, making sure that probably I don't when they upgrade to the Kubernetes version, they have to make sure that the workloads run fine. It's not an enviable job. I'm sure it's not. Let's just leave it at that and not talk about bare metal ever again. So the next one that I want to talk about is a slight segue from this. Right now, we are kind of coming into the hey, what to do, what life without containers. Now, let's talk about life without containers. And although it's hard to imagine, life without containers has actually been happening for quite a bit, especially if you're using AWS Lambda, you're already in a life without containers. Because basically AWS Lambda runs micro VM or a unikernel called Firecracker, and that's the one that actually runs your workload, your application workload, right? So we're getting into that territory now. So one of the projects that I found interesting was a project called Sysbox from a company called Nestybox, um, which is kind of interesting, the company and the name. And I'll talk about why I found this interesting. I really liked this because, and let me just share my screen in a bit. Yeah, so this is Sysbox, right? And I'm also going to share in the comments window the links to Sysbox and Nestybox. So you'll see that the cool thing with Sysbox and Sysbox is that it's essentially containers itself, right? It's not going away from the whole container, but they've created their own sort of isolated runtime, if you will. And I'll also show you a demo coming up pretty soon. So what they've done is they've essentially rewritten the runc library, right? So the runc, the thing that actually runs your container, the runtime, the lowest level runtime library that actually runs your containers, they've actually rewritten that to have a lot more isolation, right? So which means that you can run your Docker containers. It in fact uses Docker as the CLI. You can actually use Docker CLI, right? So if you see what you're doing is you're actually running Docker CLI. Let me try and get to that. Oh, yeah, you can see here. Sorry. You can see that you're actually running the Docker CLI itself, except that you're running it with a different runtime. You're running it with something called the Sysbox runc runtime. Now, what I like about this is that it's isolated because I think under the hood uses a combination of user namespaces, C groups, and then uses all the other namespaces, right? Your UID, your mount, your PID, your all of that, IPC and all of that other stuff. So user namespaces is actually an underrated feature of Docker because you can encapsulate, or you can essentially run non-root containers, right, by default, right? You can map it to user on the system, and that user need not be a root user, and you can run all your containers with that user namespace, and thereby ensuring that you don't have that massive blast radius if you do a container escape. Now, Sysbox is pretty cool. I liked Sysbox simply because one, it's very simple to use. They've really gone about the developer experience really well. What they've done is they've kind of taken the Docker CLI. They're not trying to mess with that. They've just installed their own components, right? So they just installed 3 components. I think it's the manager component, the file system component, and then the runc library. The 3 things they've installed. And they essentially use Docker CLI and run everything. So now your Docker runs with that as a Sysbox, with the Sysbox runtime, which means that you can't just have that kind of blast radius because it's running as a lower privilege user. You can run Docker in Docker without exposing the Docker socket. You can do all of that stuff, right? All the stuff that was like a taboo subject for a very long time. Don't run Docker in Docker because you'll expose the Docker socket. If you expose the Docker socket, you are essentially increasing your Docker escapes possibility. You can run Docker in Docker. You can run Kubernetes in Docker, which is a cool thing, which is essentially what the project Kind is all about, right? So Kind is essentially Kubernetes in Docker. So this, you can run that with enough isolation with system containers. I really like how Sysbox has done it. And I'm going to do a demo pretty soon on Sysbox, right? So Sysbox is essentially, sorry, you had a question, Nithin?
So this is going to be a little different from something like Kata containers, right? So this is directly changing the runc, whereas in something like Kata containers, you're going to be running your Docker containers on a micro VM or something of that
Yeah.
sort.
Kata
Right. Okay.
containers is I would say Kata is a unikernel. I mean a micro VM unikernel
Mhm.
thing itself, right? So it's not very. This is more containers. This is still in the
Mhm.
containers territory,
Got
but Kata is going to be more VM than container at this
it.
point,
Yeah.
right? For instance, Nanos is VM, Kata is VM, Firecracker is VM. So all these are VMs. They can still mount container images, but end of the day, they're still running it in a VM. So this is not doing that. This is not running it in the VM.
Got it.
So this is still a container, except that they've used C groups, they've used user namespaces to essentially isolate it better, right? And I'll explain
Mhm.
what that means. So let's see what that means, and I'll open up my demo server pretty soon. Oh, I'm opening up. Yeah, this is the one. Just give me a second while I open this up. Looks like I am still SSHing into that machine. Okay, it's taking its own sweet time. Hopefully it should be done. Ha, here we are. I'm guessing everybody can see this.
Yep. Looks good.
Okay, what happened? Okay. So basically, let me actually use Tmux and split up my screen so that we can do a bunch of interesting things on top. So basically, what has happened on this box? I've already installed Sysbox, right? I've already installed Sysbox, which automatically replaces. So one of the things Sysbox does is that it replaces the runtime parameter in the Docker daemon. So if you look at the daemon.json, which Docker uses to actually run, it replaces that with the Sysbox run C, right? So instead of the basic Docker run C, it replaces it with the Sysbox run C daemon. So every single time this runs, by default, it will run with Sysbox run C, right? So that's what it's done. And of course, you have all the other Docker features. Now, Sysbox is supposed to be 90% OCI compliant. I'm not an OCI expert, so I'm not going to get into that. But their point is that they still can't do, since they wanted to maintain a lot of compatibility with Docker, I think they still can't do the some of the they can only do read only paths. They can't read only mounts. They can't do read write mounts. There are some limitations. Obviously, they also have limitations in terms of the supported kernels and supported OS variants. Right. So this is Ubuntu. I tried this with Debian. It didn't work. So it doesn't work just like with every Linux, OS or distro out there. They have specific supported distros because I think they need to rewrite some of the proc mounts and the FS and some of that stuff. So that's why I think they're going with this. So it definitely has value, but it's not. I think I would say that unless you're meeting some of these specific cases that it will use, it may not be for you at this point, right? So that's something. And it also has an enterprise product. I don't know about that, so I can't speak to that, but it also has something called an enterprise product. Now let's actually run a Docker container. Now before I run a Docker container, let's look at the user namespace mapping, right? So if you look at this, you'll see that sub UID. If I look at the sub UID, you'll see that Sysbox has added a user called Sysbox, which is mapped to user ID 362144 and group 65,536, X number of groups. So it has UIDs, and if you look at the sub GID, that's what there is another user as well, sub GID. That's my bad. So you'll see that it's 362144. Now, when I run a container on Sysbox, it's going to map that container to this user, right? It's going to map that container to this user and use this user's namespace to essentially open up all the other namespaces. That is why it gives it better isolation. I really was always wondering when Docker introduced the user namespace remap, why that didn't become more popular as a security feature. Nobody talked about it all that much. In fact, Docker user namespace, user NS remap was really good because one of the things it did that even if you're running as root, it would automatically map to a lower privilege user, and you can't do all that much. You can still do stuff, obviously, but you can't literally like do all the kinds of crazy escapes that you could do with a privileged Docker, right? So this is one thing, and like I said, this does not mount the var Docker sock, the socket. So that's one of the things that it can do as well. So let's actually run a container with this, and I think I already have run a container. Sudo Docker. I think I have the. Oops, I think I need to. Let's actually run it from their own. I think I ran this example from their own thing. Yeah, let's run this example itself. So we're going to be running a Debian box on Sysbox. So this is going to be a Debian container image, just like any other container image. So you can see that it's going to be running with the Sysbox run C, RMIT, and then let's run Debian, right? So we are in the Debian. So if you look at the ID, you will see that it's running with root. So it's still Debian running with root. But the interesting thing is that let's actually ping something. Let's ping google.com and let's leave it running, and let's go to the lower pane and actually look at the PSAUX, right? Let's look at which user is actually running the ping. So if you look at the user that's actually running the ping, you'll see that it's mapped to that lower privilege user, which is Sysbox, right? So it's, even though inside the container you're running with root, you're still running, as far as the host is concerned, you're not running it as root. So that's one of the cool things I liked about Sysbox, because it's not, it automatically does the user NS remap, and it also adds a lot of C group restrictions. It adds, I think it also supports SecComp and AppArmor. I think AppArmor is a little bit better supported. I think they said that their SecComp support is, it's there, but it's not great. So that's what I think they've mentioned. They've mentioned that as some limitations. So they want to make this work as a first-class citizen with Kubernetes. So I think what they want to do over time is making 100% OCI compliant, so that they can run this as the runtime with Kubernetes, so that they have that isolation, right? So Kubernetes today has the standard runtime, OCI-based runtime libraries. I think one of the things that they want to do clearly, now that Docker has definitely become less of a thing, less of a force to reckon with. I think they want to they want to bring this runtime to Kubernetes. Now, this is, so I've seen some of their examples on their GitHub repo is pretty good. In fact, you can run a full Kubernetes inside a Sysbox container. So you can launch a Sysbox container. They have something called Nestybox K8s. You can actually run a Kubernetes kubeadm cluster inside Nestybox. It's pretty powerful stuff. So if you want to do like local development, things like that, it's pretty nice. You can do, if you want to run a bunch of containers as self-contained Kubernetes instances, you can do that as well. So it's kind of nice, especially for a lot of ephemeral workloads. I see this being quite extensively used. So I like Nestybox. They say that they do some kind of preload on the enterprise versions that they don't do on the community versions, which may be useful for people who want to juice the performance a little bit faster. But as a security professional, I kind of like where they're coming from. Better isolation and more scientifically provided isolation, right? So they're not just doing like random stuff. They're actually doing a proper job. They're using existing tech, but they're just improving on it through better isolation and probably better engineering from a security perspective. So I like what they've done with that, right? So this is, again, this is not Unikernels. This is still very much in the containers territory, but I like this because it's different in that it's actually taken some of the issues that we have seen with containers, especially security issues, and reframed them a different way, right? So I like that what they've done with Nestybox. I mean, with Sysbox. All right. So questions, Nithin? You have anything to add?
Oh no, this actually looks pretty interesting. Like I had not done any research on Box. It was mostly you who was working on it. So
Yeah.
I think this is the first time I'm personally seeing this, and it's pretty awesome. And we should definitely look into implementing this into some of our workflows and see if it can fit
Yeah.
in somewhere.
Yeah. By the way, we are actually doing so aside from container and Kubernetes security training that we're doing in AppSec Engineer, you should check out appsecengineer.com, right? So you can check out appsecengineer.com. We're actually doing a lot of, this time we're actually doing our first live training for the year 2021 in Troopers. So Troopers is a very respected conference that's run out of Heidelberg, Germany. Of course, we're not going to be in Germany because you know what. But I'm still really pumped for Troopers. I really love Troopers. So this is our training at Troopers. If you want to attend some live training, this is our Kubernetes security training. We're bringing a bunch of interesting stuff. I think more logging, more interesting secrets and things like that. Yeah, so it's going to be fun. So if you want to register for some live training, this is the thing to do. So, Nithin, do you want to take it away with some Unikernels?
Sure thing, absolutely. So this entire Unikernel me going down that rabbit hole essentially came in with because of multiple conversations with you and our entire team, right? So if you look at our own journey, we started off with Docker in the early days, then we moved into Rocket, and then we moved back to Docker again, and then came serverless, and we went all over it, right? So we were using serverless like this no tomorrow, and then we went into micro VMs and Firecracker and so on and so forth. So in our own journey, we were going for smaller and smaller units of compute. And I was like, okay, what comes next? Right. So there has to be something that's coming up next. And this is where I came across nano VMs or nano OS. And essentially, I started looking into it and I thought it was pretty interesting. Right. So, on a very high level, a unikernel is not going to give you any shell. There are not going to be any users. So, there's no possibility of something like a privilege escalation because there are no users. It is always going to be single process. And one additional thing is it does not rely on an underlying host operating system, right? So far, everything that we've been seeing, everything has to typically run on a host machine, like just like you mentioned before, right? So for example, something like Sysbox, it has to run on an Ubuntu or some other operating system. Even Firecracker, for example, it pretty much has to run on a machine that supports KVM, and it has to run on that particular kernel virtual machine. Not with a unikernel though, or at least not with Nano OS, right? So it does not require any underlying host operating system. And that essentially decreases the attack surface by a whole lot more, right? So unikernels on a very high level, it's going to be a single purpose compute environment. So just like Docker, right? So you're going to package your source code, you're going to package your dependencies, you're going to package all of the runtime. It's going to be the same. You are going to still need all of those things. But at the same time, it's not going to have any underlying host operating system, or it's not going to have any operating system that's going to run. It's not going to have users, and it's not going to have a shell either, right? So the possibility of getting something like a reverse shell, it's not going to exist anymore.
So it's basically
One
language runtime, I guess.
Pretty much, right? So it can be pretty language specific as well, right? So on a high level, there are going to be two types of unikernels, right? So one is your clean slate unikernels, and this is like you just mentioned, it is going to be restricted to a single language, right? So this is going to be things like your include OS or runtime JS, Mirage OS, and so on and so forth, right? So there are quite a few implementations of a clean slate unikernel. And then we also have something like a legacy unikernel, right? So, and this is where you can start running multiple services and applications across multiple languages as well, right? So this is where things like Graphene and NanoS and even projects like RumPrum come into place. I personally have played around only with NanoS. I have not been, I've looked into the other unikernel projects quite a little bit, but I've not implemented them per se, right? So on a very high level, this is what a unikernel is. Do I go ahead with the implementations, or do we have any questions?
Yeah, all right, all right, all right. Yeah. Let's see it.
Perfect. So I am personally going to be using the NanoS. I am sharing my screen right now. Looks like you'll have to. All right. It's going to zoom in a little bit. All right. So the
Yeah, a
way
little
I'm going
bit.
to be doing this, yeah. So the way I'm going to be doing this is I'm going to be building a unikernel image, right? So I'm going to be building a unikernel image. Now I cannot run this on my particular server that I have right here because I think by default hardware acceleration is going to be disabled, and it's got a bit of a problem running it on a server. But I'm going to be running it on an EC2 instance, on a T2 micro EC2 instance, right? So I have a very, very simple project. I'm just going to navigate to that particular directory. And I have a Golang HTTP file server, right? So I have a super simple, I should not have done that,
That's fine.
autocomplete. Wow.
Okay then. And it goes
It
on and
seems to be
on.
taking a while. Oh my God. It's really not a class. It's like 4 lines of code. Anyway,
You can just control C it. I think it'll stop.
it did not work. Trust me, I tried it multiple times.
Oh, okay. Okay. Yeah, it seems to be working now.
I'm not going to do that mistake again. Okay. So this is all it is, right? So I have a static file server which has the HTML file, which is going to say, welcome to AppSec Engineer, and it's going to be listening on port 8080. So this is a super simple Golang file server. And I also have a config.json, and this is where I'm going to store all of my necessary configurations, right? So let's quickly have a look at this particular file as well. So the directory that I want to upload onto the particular image that I'm trying to create is going to be static, because static has the entire index.html. The project ID, it's not really necessary. It's just a test project. There is no project with that name. The region I am going to be deploying to is going to be US West 2. And I've also created a bucket, right? So a bucket is going to be important for creation of the image. And while I'm going to be updating that image or uploading that image to the AMI, that's where the S3 bucket comes into play, right? So it is going to require extra permissions for your user, your AWS user. So please do keep that in mind. So I have all of this ready right here. And what I'm going to do right now is I'm going to go ahead and start creating this particular image, right? So I'm going to say, uh, by the way, I am going to be using the CLI of NanoOS called Ops. Now, Ops is a orchestrator for NanoOS Unikernels, right? So if I want to build a Unikernel image, or if I want to go ahead and deploy it on either GCP or AWS or even DigitalOcean, I can go ahead and start using Ops. You can find it on ops.city. So anyways, I'm going to clear my screen, and I'm going to say ops create. The target where I'm going to try and deploy this is going to be on AWS. I have my configuration file, and I want to go ahead and create a server, right? So that's the image that I want to go ahead and create. And if I try to list it, I am hoping it works. I'm going to say US 2.
So does it create an EC2 for every single image? One EC2 per
Uh,
image?
it does. You can
Okay.
run, yes, it's going to be EC2 for every single image. I am not sure what the
Okay.
problem is right here. Let me look into it.
You don't have the right permission, is what it's saying.
I'm just going to head over to my AWS console and try to change it. I thought I'd given it the necessary permissions,
That's
but
fine.
I'm just
We're on
not
live
getting
code, so it's okay. Nothing's going to work.
demo gods hate us. All right. I'm hoping it works now.
Okay.
I'm just going to try and rerun it. If it works, great. If it does not, then you're going to have to refer to my blog.
Yeah, you can just share that link with me.
I can, yes. Bear with me for 1 second.
VM import role.
I did create it, but I'm not sure
Oh,
why it's causing. I'm just going to share it with you on private chat. You can go ahead and share it there.
yeah.
I can probably do a demo and release it on YouTube at a later point. That shouldn't be a problem.
Yeah.
But essentially, on a very high level, the way this would work is it's going to create an AMI or a Amazon machine image for you, and that is essentially going to be deployed as an EC2 instance. And you can essentially access this particular application, super simple file server, on an EC2 instance. Now, one additional functionality that they also provide is they claim that they can apparently run it on Kubernetes, right? So, which is what I'm pretty excited to test out at a later point. I want to go ahead and test this out on Kubernetes, and I want to see if that works, and if we can start deploying some of our workflows on it.
Yeah, I think this is going to be, I think, what the future holds for us. Because if you look at Firecracker, it's essentially purpose based. So it's just, one language runtime.
Mhm.
They load the language runtime with the basic binaries. You can bring your own third party libraries and then load it. and then run your code. So I think that's what we're going to go. I think that's why Firecracker has also become GA. It's on GitHub and it's available for people to use. I've seen a lot of people orchestrate with Firecracker as well. In fact, Nomad, which is another or the container orchestration tool, has a pretty nice and uh, reasonably mature Firecracker orchestration system. So it's actually kind of nice how Nomad does it. It's pretty nice. They actually have it. So I think this is the way we're going to see a lot of these things move, right? So more than containers, or I think we're going to see a lot of these unikernels take over because they're safer, right? They're just safer. They're literally from a security perspective, they're way safer. The possibilities of doing, privilege escalation, yes, you can still do it, but the blast radius of that privilege escalation definitely is lower. All those things are definitely better, and you can still do a few things, but I really I prefer these because you're able to get that same isolation as a VM. At the same time, you're still leveraging,
So
containerized
supply
images,
chain
containerized.
attacks. So you
Yeah.
think supply chain attacks will continue to play a role, even with Unikernels?
See, the end of the day, they're still using libraries and they're still using container images, and all those things can be subject to all kinds of issues, right? So then we've seen this in the past. So I don't think that's going to change that much, but it's definitely so the whole Docker being isolated thing, it's definitely going to do away with that myth, right? It's not containers are
Yeah,
not isolated. This truly is because
this
you
is
are using low-level virtualization to be able to achieve this, which is much better than using containers, in my opinion. But again, I'm sure it'll come with its own set of operational challenges. I think other than AWS who have done it for themselves, I'm yet to see a vendor neutral service. I think Nanos comes close. I'm not sure if there's anybody else in that space, but other than AWS, I think none of them have run it as a general purpose compute thing, right? So, and it'll be really interesting if they can do that. That's something that I want to see. I think we'll see that also in the coming few days. So on. Right. All right. Anything else to add, Nithin? I think I'm done with what we had to say on life beyond Docker, right? So we've talked about a bunch
yeah.
of things today.
Yeah. One thing that I do want to note is we are actually in talks of planning a course around this as well, right? So Life Beyond Docker or the other options for AppSec Engineer, we are currently in plans of creating a separate course. So the folks who are watching this, if you want us to, include something else or some other potential options, do let us know in the comments below. And we probably will look into it and, consider making a course out of that as well.
Yeah, that's the idea. So in AppSec Engineer, we want to create small courses that are security specific, don't take too much time to learn, and we want to put them up on AppSec Engineer. So you should definitely give us some ideas. We're already thinking of a bunch of them that we're going to release over the next couple of months. But yeah, so we already have 22 courses. I think by the end of March, I think we'll have 40 change. So it's going to be pretty interesting. Yeah, right. All right. So I think we're going to be closing the stream. Any questions before we close our stream? Let me know. Yeah, looks like there are no questions.
All right, folks.
Still
I think.
Yeah, there are no questions, I guess. All right, thanks so much, and we'll see you in another stream or another video. Do like and subscribe to this channel on YouTube, LinkedIn. Please follow us on LinkedIn and YouTube. Definitely, we keep putting out content like this. We think it's pretty awesome. A lot of the people who like us think it's pretty awesome. So I hope you enjoyed as well. And we'll see you in our next video or next live stream. Thanks so much. Thanks, Nithin, and have a good morning, good evening, good night, wherever you are.
Sure.
Bye-bye.
Bye-bye, folks. See you.